So now let's study about different types of relation. Now this is an important topic. However, mostly this is going to be a theory topic. Still being a theory topic, JEE loves to ask question from this topic. So whenever there has been a direct question from this chapter, it has either been from types of relation or it has been some other type of numerical question from sets. So keep in mind this topic. This is an important topic for you to study. What are the different types? First is an empty relation. An empty relation in which no element of set A is related to set B. That time we get an empty relation. Universal relation. That means all elements of set A are somehow or the other related to set B. So these two are very simple. Now comes the difficult part. What is an identity relation? Identity relation means that each element of set A can be related to set itself. So let's say if I have in my set A, let me assume this is my set A, I have 1, 2 and 3. So now this is the set that I'm using. Now let's say if I write down one of my relation set as 1, 1, 2, 2, 3, 3. That means all elements are related to themselves. 1 is related to itself 1, 2 is related to itself 2, 3 is related to itself. Then we call this as an identity relation. However, we would call this an identity relation only and only if all elements are related to itself. This is only. However, when we talk about a reflexive relation, this is also the same thing. Each element should be related to itself. However, it is not necessary that only those elements need to be related to itself. Now let's say if I have R is equals to, for the same set, if I have 1, 1, 2, 2, 3, 3. Now let's say if I also have 1, 3 as well in my set, then this wouldn't be an identity relation now, because there is one relation in which the element is not related to itself. So this would now become a reflexive relation. Reflexive relation. So this becomes a reflexive relation. I hope you are understanding the difference here. So in identity relation, each element should be related to itself and the relation should have only those items of same side relation. However, when we talk about reflexive, each element should be related to itself as well as there can be other relations as well in that set. So from here, what is one conclusion that we can find out? Every identity relation is a reflexive relation, However, the vice versa is not true. Not all reflexive relations are identity relations, but some reflexive relations are identity. Let's say if I remove 1, 3 from this set, then it would become a reflexive relation as well as it would be an identity relation. So keep these things in mind. Now talking about symmetric relation, let's say if in my set I have A is related to B and I also have one more element where B is related to A, then this becomes a symmetric relation. So a relation R is symmetric if A, B belongs to relation is also B, A belongs to that same relation. In other words, if one element is related to another, then the second element is related back to the first. Now talking about transitive relation, a relation R is transitive if A is related to B and let's say if B is related to C, then A should also be related to C. So from transitive, what can we make out? That A is related to B and B is related to C. Then what do we find out the conclusion? A is also related to C. If this is the case, then we can say that it is a transitive relation. Now what is an equivalence relation? Equivalence relation is nothing but if let's say if I have a relation which is all three, reflexive, symmetric and transitive, then we call it an equivalence relation. If any one of them is not satisfied, let's say it is symmetric and transitive but not reflexive, then we are not going to call it as an equivalence relation. Now antisymmetric relation. What is antisymmetric relation? Each and every element in my set, if it is related back to itself, then if it is not related back to itself, then we can call it an antisymmetric relation. So for example, here let's take this example only for instance. A is equals to 1, 2, 3. There is a relation defined 1, 1, 2, 2, 3, 3 and 1, 2. Now I can see 1 is related to 1. Now let's see if the latter is also true. Is 1 related to 1? Let's say this is my A, this is my B. For this particular section 1, 1, A is related to B and B is also related to A, because even if I write down the reversal, it is still going to stay 1, 1. That means it is true. For 2, 2 also the same thing. 3, 3 also the same thing. For 1, 2, I can see A, let's say if my A is 1, B is 2. 1 is related to 2. However, is my 2 related to 1? No, there is no such element where 2 is related to 1. Then we call this relation as an antisymmetric relation. Had, let's say, we would have in this set only, let's say if I would have 2, 1 as well, then it would no longer be an antisymmetric, it would have become a symmetric relation. Now one thing that you need to keep in mind, that if my relation is not symmetric, let's say if I check and my relation does not come out to be symmetric, this does not mean that it is antisymmetric. It can still be not antisymmetric. So let me write that line down for you. If relation is not symmetric, does not mean relation is antisymmetric. Still there can be elements that define it to not be an antisymmetric relation. So keep this point in mind. Let's look at this example. Based on this example, I think all of your doubts regarding this types of relation would be clear. So mainly these were all the major types of relation. Generally what JEE does is it asks question from this equivalence relation. They're going to give you a relation and then they are going to ask you whether it is an equivalence or not. So to check whether it is an equivalence relation or not, you have to check whether it is reflexive, you have to check whether it is symmetric, whether it is transitive. Based on these three, then you would be able to justify your answer. So let's look at this question first. Let R1 and R2 be two relations defined on R by, where A is related to B such that AB is always greater than or equal to 0. So, and then there is another relation as well. So let us solve this question one by one. Let us take the first relation for instance, where A is related to B, given that AB should always be greater than or equal to 0. Now I have to check whether this is equivalence or not. So for equivalence, what were my conditions? For equivalence relation, my conditions used to be that it should be reflexive, it should be symmetric, as well as it should be transitive. It should be all three. If it is all three, then I can say it is an equivalence relation. So let me check for the reflexive condition. What used to be the reflexive condition? That each element should be related to itself. Let's say if I have A related to A, then this would become A into A greater than or equal to 0. A square, would this be always greater than or equal to 0? Yes, they have not told us anything about A and B. So what are we going to consider? That A and B are either positive numbers or negative numbers. Let's say if A is a negative number. Let's say if A is a negative number. So if A is a negative number, A square would become positive. It is greater than or equal to 0. If A is positive, then simply of course it is going to be greater than 0. If A is 0, still 0 would be greater than or equal to 0. The equality is there, right? So it satisfies all these three cases. That means it is a reflexive relation. So one thing we found out, that it is a reflexive relation. Now let us check for symmetric. Now let's check whether it is symmetric or not. If A is related to B, then we have AB greater than or equal to 0. If B would be related to A, then would we have the same thing as BA greater than or equal to 0. So you can see that A into B or B into A, both are the same thing. So that means this can also be written down as AB greater than equal to 0. That means these two are satisfied. That means this is also a symmetric relation. Now let us check for transitive. What does transitive say? That A, if it is related to B, where we say that AB is greater than 0, and we are saying that B is related to C, given that BC is greater than 0, then A should also be related to C, given that AC should be greater than equal to 0. Now we have to check whether this condition would be satisfied for all cases or not. So what you can do simply here is use hit and trial method. Let me use hit and trial method. If I use hit and trial method, let's say if I assume, let me take a few example of positive, negative values, 0 values, and then let's see if it is coming out to be true. Let's say if I take A to be 5 and B to be 0. If A is 5, B is 0, this condition would be satisfied. If B is 0, let me take my C to be minus 5. I'm taking all three values together so that I will understand whether it is transitive or not. Now for BC, B into C, this would also give us 0. 0 is greater than equal to 0. So this is also satisfied. Now we have to check whether A and C would be satisfied or not. If I multiply A and C, I'm going to get minus 25, which is not true. So I have found out in my first hit and trial case only that there is one condition where it is not coming out to be transitive. That means it is not transitive, so it is not equivalence. So it is not equivalence. So here in the question, R1 is not equivalent. So this option is cancelled out. This option is also cancelled out. Sorry, this first option is cancelled out where they've said that R1 is an equivalence relation, and C option is also cancelled out because here also they are saying that R1 is an equivalence. Now let us check for R2. Similarly, for R2 we are going to check one by one. For A, B, when they are mapped, when they've said that A is greater than B. So let us first check for reflexive. Each element should be mapped to itself. That means if I have A related to A, wouldn't this imply that A is greater than equal to A? This would be satisfied in all cases because A would be equal to A, and there is in this equality there is equals to sign as well. So this is always true. So it is reflexive always. Let us check for symmetric. Now while checking for symmetric, what we do is A related to B. We say that A is greater than equal to B. Now let's say if I have B related to A, would B always be greater than equal to A? Now here what you can see is both these conditions need to be satisfied together. A is greater than equal to B and B is greater than equal to A. Now this can be satisfied only when I have A is equals to B. Only then this condition can be satisfied. If let's say both of A and B are different, A is 5, B is 3, then would the vice versa be true? 3 greater than equal to 5? No. That means it is not a symmetric function. That means now we do not need to check for transitive. Since we know it is not symmetric, that means it is not going to be an equivalence relation. That means what do we get? Neither R1 nor R2, neither of them are equivalence relations. So I hope you must have gotten a gist as to how you are supposed to solve questions related to reflexive, symmetric and transitive relations. Let's look at one more question. Let R be a relation defined on natural number as A related to B if 2A plus 3B is a multiple of 5, then R is. So we need to find out whether or not it is reflexive, transitive, symmetric or an equivalence relation. So what we do is first we start checking with reflexive relation. So we know A is related to B, then 2A plus 3B. This is a multiple of 5. That means I can write it down as 5x. X be whatever value, I can say it is 5x. Now let me check for reflexive first. If I have A related to A, then this would become 2A plus 3A is equals to 5x. This would become 5A is equals to 5x. So from here I can see that since I have a 5 here, I have a 5 here as well. So it is going to be satisfied. That means a would still be equals to x, right? I mean, it is still going to be a multiple of 5, right? This, our point was we had to check whether this entire term is a multiple of 5 or not. So it is going to be a multiple of 5. Here we have a 5, right? Let's say instead of 5, I would have had 2 here. Then it would have become 5 by 2x. Then we are not sure. For certain values, we might have a point values as well. So here we can say that it is always reflexive. Now let us check for symmetric. If a is related to b in such a way that 2a plus 3b is equals to 5x, then b should also be related to a. 2b plus 3a should also be a multiple of 5. So now we have to prove somehow that 5x and 5y, both these are proportional or they are equal. That means if I am able to prove that, that means I can say it is symmetric. So from here what I'll do is I'll try to convert this equation in this format so that I can get, I'll see if it is a multiple or not. So I have 2a plus 3b is equals to 5x. So from here what I can do is I can take, if I was to convert it into this equation, and let's say if I put the value of, let's say if I put the value of a from this equation into this equation, what would it become? I have a as 5x minus 3b by 2. So if I replace this value in this equation, sorry, not this one, if I replace that value in this equation where I have assuming this to be 5y, if I replace this a value, this would become 2b plus 3 times of 5x minus 3b by 2 is equals to 5y. Now let's see. Now let's try to convert this into 2b plus 3a. So this would become 2b. Sorry, this would become 2b is equals to so this can be written as 5y minus 3 by 2 times of 5x minus 3b. So from here what I'll do is I'll add 3a again in this equation. 2b plus 3a, this should be equal to 5y minus 3 by 2 5x minus 3b plus 3 times of, sorry, so my point here is, can I convert this equation in, let's say, a multiple of 5? So let me try it out. So what I can do is I can take 2 as LCM. So this would become 4b plus this would become 15x minus 9b by 2. So from here what I'll do is so this would basically become minus 5b plus 15x by 2. So from here I can see that I can take 5 common. Then this would become, basically this would become 3x. I can take 5 by 2 common, sorry. This would become 3x minus b. Now, can I write 3x? Now from here I know that 2a plus 3b is 5x. So how can I write down my 3x? So my 3x, wouldn't it be written down as 2a plus 3b So from here, what I can do is this 2a plus 3b is equals to 5x. Now what I'm saying is, can I write this 5x as 3x plus 2x? Then what would it become? It would become 2a plus 3b is equals to 3x plus 2x. Now what I'll do is I'll take this 2x to the other side. Then I would have the value of 3x as 2a plus 3b minus 2x. Now let me replace this 3x value here. So this would become 5 by 2. This 3x would become 2a plus 3b. I also have a minus b here. So this would become plus 2b and minus 2x. Now I can take this 2 common here. This 2, all of them would be cancelled out. And I am left with 5 a plus b minus x. That means I've gotten it to be a multiple of 5. That means my y here, my y value here, it is going to come out to be a natural number a plus b minus x, right? That means it is symmetric. We've gotten this value as well. Now let us check whether it is transitive or not. For transitive, what I'm saying is that for transitive, if a is related to b, that time we have 2a plus 3b is equals to 5x. And if b is related to c, that time we have 2b plus 3c is equals to 5, let's say y. Now for it to be transitive, we need to have a related to c in such a way that 2a plus 3c should be equal to 5, let's say z. This is what I need to prove. So now using these two equations, what I'm going to do is I'm going to prove whether 2a plus 3c comes out to be a multiple of 5. If it doesn't come out to be a multiple of 5, we'll simply say that it is not transitive. So from here, what I'll do is I'll add these two equations. If I add these two equations, what do I get? 2a plus 5b plus 3c. This comes out to be 5 of x plus y. Now this 5b, I can take it to the other side. So this would become 2a plus 3b is equals to 5 x plus y minus 5b. Now again, I can take 5 common from this equation. So this would become x plus y minus b. So that means you all can see, sorry, this is 3c. That 2a plus 3c is coming out to be again a multiple of 5. That means it is transitive as well. That means this entire equation is reflexive as well as symmetric as well as transitive. So it is an equivalence relation. So I hope you must have understood. I'll just repeat the flow of this question once again. First of all, what we do is we check whether our relation is reflexive or not. We checked it. We put a and b both similar. It came out to be a multiple of 5. So it is a reflexive function. For symmetric, we replaced b with a. Then we tried to convert it in such a way that we got it to be a multiple of 5. We used replaced the value of a here in this b, 2b plus 3a. We replaced the value of a as b. Then we got certain value. After that certain value, what we did was we replaced 3x from this equation as well to see if there are any chances that it can come out to be a multiple of 5. And yes, this 2 was simply cancelled out from each and every term and we got it to be a multiple of 5. For transitive also, what we did was we simply added the two relations, a related to b and b related to c. We simply got our answer. So that is how you generally check whether your function is reflexive, symmetric and transitive. So that was all about the theory portion of this chapter. Major and major, each and everything has been covered in this chapter, and this was just a basic chapter, another short one, a short chapter, and mostly there are not too many direct questions that are asked from this chapter. However, there have been a few questions. We'll look at that in the next lecture.